Okay, let's continue with section 2.3, but before we do that, just remember, I wanted to just review this one more time. It probably will come up again, so it's good that we make sure we understand it. So this is what? These are the relative frequency, I'm sorry, no, these are the frequencies for each of the classes, right? So it's this one, and this one, and this one, and this one. And when we sum them up, we have to get the total amount of data. So when we sum, this means sum them up, and this means this, sum them up, and we should get the total number of pieces of data. Okay? And they say the number of observations in the sample is usually, denoted by n. Thus, for the sample, we say that this is equal to n, right? Sorry. This is equal to n, right? Because n stands for 30 here. Okay? All right, now let's go back to here. We're talking about the relative frequency and the percentage distributions for, now we did this already, but we did it for qualitative. Now we're doing it for quantitative, for numerical data. Okay? So the relative frequency of a class, still, remember, because what we did was we took quantitative data and we made classes, and so then we could say, like, between 5 and 9, how many were there? Between 10 and 14, how many are there? Then all we're doing now is taking, again, the same thing that we did before. We're taking 3 divided by 30, 6 divided by 30, 8 divided by 30, 8 divided by 30, and 5 divided by 30, and those are called what? The relative frequencies. And then the percentage distributions will be also the same. So we can say the relative frequency of a class, this is of a class, just one class, is the frequency of that one class divided by all of the data, or in other words, the sum of all of the frequencies, right? And that can be written symbolically. The frequency of the class is f. Usually, well, like f sub 1 or f sub 2 or whatever, but they're just writing f here. It's okay. Divided by the sum of all the f's. That's what this means. Okay? And then again, just like before, when we did it for qualitative data, now just like that, but now for quantitative, we can get the percentage by taking the relative frequency, which is here, and multiplying it times 100. So here's an example, and I think you can go through this yourself. And the graphing group data, section 2.34. So instead of what we called a bar chart before, we're going to make a histogram now. We're also going to talk about doing this, but the main point is here. And then they say you can also do a pie chart, but the procedure is basically the same as we did before, so they're not going to repeat that again. Okay, so a histogram is very similar to a bar chart, slightly different, but not really much different. So really, the only difference between a histogram and a bar chart is that with a bar chart, this was a bar chart from before, these bars don't touch each other, that's all. That's the only difference. So when we draw a histogram, the bars touch each other. Okay, so that's the basic difference between them. So we have the categories here, or the classes. So this was for iPod sold, and in some locations, I guess it was a number between 5 and 9. In other locations, it was a number between 10 and 14, 15 and 19, 20 and 24, 25 and 29. And so how many times did we get something in this range? We got 3. How many times did we get something in this range? We got 6. How many times did we get something in this range? We got 8. In this range, 8. In this range, 5. Okay? So that was an example of a histogram. A histogram is a graph in which classes are marked on the horizontal axis. So the classes are on this axis, on the x-axis. And the frequencies are marked on the vertical axis here. Frequencies are marked on the vertical axis. But we, just like before, we could do it with frequency, but we could also do it with relative frequencies. So the frequencies or the relative frequencies or the percentages are represented by the heights of the bars. In a histogram, the bars are drawn adjacent to each other, means they're touching each other. So here's the frequency. And the relative frequency is what? How do we get the relative frequency from the frequency? This was 3, and the total amount of data, I think, was 30. So this is 3 divided by 30, which is 10%, right? And this one is 6. So 6 divided by 30, which is 20%, and so on. So we get 10%, 20%, and so on. So the shape is exactly the same. It's just that the y-axis is different. The numbers are different. These are the actual numbers of iPods that were sold, I think, or something like that. And this is the relative frequency of those numbers. Then instead of doing it that way, you can also do it this way. So you can say between 5 and 9, we said there were 3, so you put a dot here in the middle of this interval. And remember, we talked about how to get the middle, the midpoint. Okay, and then the midpoint for here is here, and that was 6, so we'll put a dot there, and here, and so on. So it's the same idea. You had, before we had a bar here, and then a bar here, and we're just taking the midpoint at the top, the midpoint at the top, midpoint at the top, midpoint at the top, and then we go from, we draw down to 0 here, and down to 0 here. Okay? So a polygon is another device. It's called a polygon. This is called a polygon. A polygon is another device that can be used to present quantitative data in graphic form. To draw a frequency polygon, we just saw how to do that, so I won't go through it again. You can read it. A polygon with relative frequencies marked on the vertical axis is called a relative frequency polygon. So here, this was just the frequency polygon, but if we had done relative frequencies, then these numbers would be different. The shape would still be the same. A graph formed by joining the midpoints of the tops of successive bars in a histogram with straight lines is called a polygon. Okay. Now in the next picture down here, what happened? Well, if we had lots of data, here we only had 30 iPods that were sold. But suppose we're talking about all the iPods in the world, so maybe there's like, I don't know how many millions. Let's say there's 100 million. So then we'd say, we'd have to go from, I don't know, these numbers would go from small to much, much bigger. And then, so the intervals we'd have to have a lot more intervals in here. Or we could have a lot more intervals because we have so much data. So then these bars get narrower and narrower because we have to fit more and more bars into this, say, from here to here. So if we do that, if we can do that because we have so much data that we could do that, then the bars become very thin, and so the histogram looks more and more kind of smooth. And the polygon gets kind of smoother and smoother, whereas as opposed to this one, which is kind of bumpy. But if we had more and more, it would look smoother. For a very large data set, as the number of classes is increased, so as we increase the number of classes, and then the width of the classes is decreased. So if we can do that, the frequency polygon eventually becomes a smooth curve. Such a curve is called a frequency distribution curve. So instead of calling it a histogram, we call it a frequency distribution curve. So when it gets smooth, then we refer to it as a frequency distribution curve, or simply a frequency curve. Figure 2.6 shows the frequency curve for a large data set with a large number of classes. Okay, let's stop the video and then come back to here. We'll do this, and then you can do the homework for this section.